This problem is taken from Cambridge Mechanics book. It will be about the non-equilibrium problems and finding resultant forces and directions of acceleration. Okay, here's the problem. A boat of mass 100 kilogram experiences a force of 13 Newton eastward from the wind and a force of 14 Newton from the tide on a bearing of 35 degrees as shown in the diagram. Find the direction of the subsequent motion and the acceleration. Let's get the diagram. Okay, so this is the diagram. So in the diagram, what you can see here, we have the two forces. We have 30 Newton, and the other one is 40 Newton. So this is your 30 Newton force, which is eastward from the wind, and this is your 40 Newton. So from the tide, and it is having a bearing of 35 degrees. So as shown in the diagram. So the problem is asking us to find the direction of the subsequent motion and also the acceleration. So when we're going to answer this problem, what we need to do is that we need to draw a diagram with the resultant force to show where the angle is being measured from. Okay, so if we're going to draw your diagram, the diagram will look like this. Okay, your diagram must look like this. Okay, so this diagram is showing the direction of motion. So here, basically, if we're going to show the resultant force, so we can measure it with using the angle which is our theta here. So when we're going to add vectors, it is equivalent to drawing them end to end. So what we're going to do with the forces here on the first diagram or on the original diagram is that we're going to draw the forces end to end. So it means that we are just also adding the vectors. This is the equivalent of adding your vectors. So this given forces on the diagram, we can draw it like this. You can draw it end to end. So we have first your 13 Newton. So the direction is going to the east. This one. Okay. So after that, we can draw the 14 Newton. Let's use another color. So we can just write the 14 Newton going in there. Okay, so this is the 14 Newton, and this is your 30 Newton. So with this, we can just show or draw our direction of motion. Let's have an illustration here, which will combine the two forces. Okay. Okay. So meaning to say, this will be your direction of motion. This will be the direction of motion. You can just use a broken line for this actually, so that we can say that this is not a force. Let's just use a broken line. Okay, so that we will know that this is the direction of motion, or this will give us an idea that this will be our resultant force. So this is your direction of motion. Direction of motion. Now, so let's try to put the angles inside. So here, as you can see on the first diagram, the bearing is 35 degrees. So the 35 degrees is here. Okay, it's between the north and the 14 Newton. Now, this force, we were able to draw it on the end of the 13 Newton force. So what happened here basically is we will be forming an obtuse angle. And this obtuse angle will be 90 plus the 35 degrees in here. So that's why this angle will be 90 and 35. This will become 125 degrees. This will be your 125 degrees. Okay, that will be your 125 degrees. Next, here we're going to have our data. Data will be there. And this time, we can use the cosine rule to find the resultant. So this will be our resultant, the broken line. Okay, we will find using the cosine rule. Now, take note that the cosine rule, one of the side, let's say c squared, or the c. So that will be c squared is equal to a squared plus b squared minus 2ab, and then the cosine of c. It depends on the angle that is facing the side. Just like, for instance, in this given, so if we will consider the resultant, our resultant is this. For example, let's say this is our r here. For example, we will make it our r here. So if we're going to use our cosine rule, this will be the side and this will be the angle. So with the formula, let me write the formula again. Okay, cosine. So for example, let's say c squared. So that will be c squared equals a squared plus b squared minus 2ab, and then times the cosine of the c. So that will be the angle that is opposite to the side that you are solving. So again, this is called your cosine rule. Okay, we've learned it on the previous lesson. So these are basic trigonometry rules, cosine rule and your sine rule as well. Okay, so let's get started. Let's solve for the r. So if we will be solving for the r, you will have We'll have here your r squared. There'll be r squared. Excuse me. Is equal to 30 squared plus 40 squared minus 2 times 30 times 40. Cosine of the given angle there is 125. So it doesn't fit. Wait, let me adjust it. Okay, let's do it again. 40 squared. Okay, so that's 40 squared minus 2 times 30 times 40 cosine of 125. I hope it's okay. Okay, it's visible. Now, so after this, we can just use your calculator directly. So meaning to say, this will be equal to r, which will be equal to the square root of 30 squared plus 40 squared minus 2 times 30 times 40 cosine of 125. So please make sure that your calculator was set in degrees, or else you're going to have a different answer. So approximately, we're going to express the answer in one decimal place to give us 62, to give us 62.3 Newton. So we're going to express it in decimal place, in one decimal place, but it depends. It always depends on the instruction. So most likely, the one that is always expressed in one decimal place is the angle. Angle is always in one decimal place, or if not, it will be in the nearest whole number. Now, so we already have your resultant. The next thing that we're going to do is that we're going to solve for the acceleration. So remember that acceleration is one of the problem in the given. So let's solve. So to be able to solve for your acceleration, what we're going to do here is that we're going to use the second law of Newton. So remember Newton's second law. So let's put some barrier here. So Newton's second law is F is equal to ma, or the force is equal to the mass times the acceleration. So here, we already solved for the r, which is 62.3 Newton. So therefore, we can just substitute here. We can have r is equal to 100, which is the mass, and then the acceleration is unknown. That is the problem. So substitute. So this will give us acceleration is equal to 62.3 divided by 100. So approximately our acceleration is 0.623 meter per second squared. So this is your acceleration. So we're done with the acceleration problem. Now, next, we need to find the angle, okay? This theta. We need to find the theta so that we will be able to solve for the direction of motion afterwards. Remember that in this problem, we made use of bearing. Okay, we made use of bearing. So therefore, in the final result for the direction of the motion, we need to express also our answer in terms of bearing. Okay, so let's get started. So here, we will be utilizing the sine rule. Okay, we will utilize the sine rule to find the angle. So as you can see, we were able to solve our resultant already, which is 62.3. So if we're going to use the sine rule, so that will be, remember that the sine rule, for our sine rule, is only A over sine A equals B over sine B equals C over sine C. Okay, so here, if we will use your sine rule, so that will be, we will have, 40 all over sine theta is equal to R all over sine 125. So we will just go with the opposite side and angle. So R is opposite with the 125 degree, and then the theta is opposite to the 40 Newton side. Now, if we're going to do cross multiplication, we're going to arrive with, so just do cross multiplication and solve for the theta. Just use the calculator. So here, you'll be able to arrive with the theta. So the theta here will be equal to 31.8 degrees. So this will be our theta. But this is not yet the final answer, because as what I've said, the answer, the direction of motion was expressed in terms of bearing. So therefore, when we're going to write our final answer for the direction of motion, it will also be, or it must be, in terms of bearing. So what are we going to do here to be able to find the final answer? So we will just have 90 degrees. We will have 90 minus 31.8 degrees. Okay, so if we will use our calculator, so that will be 90 minus 31.8 degrees. So it will give us 58.2 degrees. It will give us 58.2 degrees, or we can just round it up to 58 degrees. So we can say that direction of motion is on a bearing of 58 degrees. Okay, we can say that the direction will be on a bearing of 58 degrees. Okay, so that's the result. So here we will just do the cross multiplication and solve for the theta. So we've learned it on the earlier topics on trigonometry and also in equilibrium problems.